Okay guys, here we go with our lever lab. Now everybody in here is familiar with the use of a seesaw type lever. Alright, you all know how levers work. Remember that the point in the middle is called the fulcrum, and then we have on our lever, you have an arm of resistance on the left. You'll notice that resistance is already there, and an arm of effort on the right, which is AE. No, not American Eagle. Notice that there's a hook hanging on the right, the effort side. That's where you'll be adding weights. And the resistance on the left is always going to remain 500 grams, as it says on your paper. Now, I did a little color coding here to kind of help you think about this. Notice that that first column is effort arm, second column is resistance arm. Notice that the resistance arm, that length changes. So there's open holes on the resistance arm side. You may or may not be able to see it here, but you can see that there's green tape over the AE side, so you won't be moving the arm of effort, you will be moving the arm of resistance. When you come back, you're going to be using the IMA column in red to divide the arm of effort divided by the arm of resistance. That's going to calculate your ideal mechanical advantage, and then you're going to use that information to help you predict the amount of mass or effort that you will need to put on the arm of effort side, the empty hook. So let's take a look at what you'll need to do. First of all, you want to make sure to start that your resistance is on the 50 centimeter side. That's the first one you'll be able to do. The first one that's done for you has the arm of resistance at 60 centimeters, but this only goes to 50, so we obviously can't do that one. That is why that one is done for you. All right, so we have our resistance arm at 50 centimeters. We have 500 grams of resistance here, and let's take a look at what you'll need to do. All right, so again, effort arm is always going to remain at 50 centimeters. So for our IMA, we'll divide 50 divided by 50, and that will give you 1. You're going to use that number 1, that ideal mechanical advantage of 1, in this column, in the predict column, to divide your resistance, 500, divided by that IMA that we just got, 1. 500 divided by 1 should equal 500, so that's going to tell us we should get away with putting 500 grams of mass on the hook on the right. Let's take a look. Now keep in mind that this hook weighs 50 grams. So we need to add 450 grams to get to 500. Here are two 200s. There's 450, and here's 500. Now, doesn't work. All right, you might remember from our talks that we're not using laboratory grade equipment here, so you might have to cheat a little bit. And once you kind of do that, you can see that okay, that works. All right. Now let's just see if we put 520 on there. That's too much. If we put 470 on there, that's not enough. So it just kind of goes to show you that even though our equipment isn't 100% accurate, it is close enough for classroom results. All right, you'll go through and complete that for each of the different resistance arm lengths. You should notice your effort changing each time, and then there's some questions for you to answer at the bottom. And then after you're done with that, flip it over, and you have some calculations to do on the back. It does say you can work with your lab group. However, I'm not really going to give you much input or help on that, so you're going to have to work through that. You have a formula up above that should help you. All right. Please make sure your weights are racked when you're done, and put your name on your paper like I did, and then put it in the bin if I ask you to. Go to it.